This video is going to take you through the steps of how to do dimensional analysis problems. Dimensional analysis is a really important concept in chemistry, and it's something that we're going to keep using all year in different forms. So it's very important that you pay really good attention to the stuff in this video, and you may actually want to go back and watch it again later. The first thing you have to know about dimensional analysis is how to make conversion factors. So conversion factors are basically just fractions in which the numerator and the denominator are equal quantities, but they're expressed in different units. So for example, 1 inch is equal to 2.54 centimeters. If I said something was an inch tall, it's also 2.54 centimeters tall because that's the conversion factor between inches and centimeters. It's the same thing as saying like 12 eggs equals 1 dozen eggs. It's still the same thing. It's 12 eggs either way. It's just that's how you would convert from single eggs to dozens. That's what conversion factors are all about. They're equal quantities, but they're expressed in different units. So going back to our example of inches to centimeters, there's two factors that we could use, two conversion factors that we can make out of this relationship. So if our relationship is that 1 inch is equal to 2.54 centimeters, we could make one conversion factor that's 1 inch over 2.54 centimeters, or we could make another one that's 2.54 centimeters over 1 inch. Those are the two conversion factors that we would get out of this one relationship. So now we can do a little more practice on writing conversion factors. So with things that we know the relationship, like liters and milliliters, we know that in 1 liter, there's 1,000 milliliters. So what two conversion factors could you make out of that? Well, you could do 1 liter over 1,000 milliliters, or you could do 1,000 milliliters over 1 liter. What about hours and minutes? We know in every 1 hour, there's 60 minutes, right? So the two conversion factors we can make there is 1 hour over 60 minutes, or 60 minutes over 1 hour. You do the same thing with meters and kilometers. So you try that one on your own. See if you can figure out what the relationship and the conversion factors are for meters and kilometers. So now let's look at an example of a dimensional analysis problem where you would use a conversion factor. So the question is up here. How many minutes are in 2.5 hours? So we can solve this using dimensional analysis. What you always do is you start with your given value. So your given value was 2.5 hours. You have to make sure you write the number and the unit. And sometimes we put that over 1 just to keep things all as fractions. It's a little bit easier to look at that way. And then we're going to multiply that by the conversion factor. So our conversion factor, just like what we made in the last slide, for minutes and hours is that in every 1 hour, there's 60 minutes. So we're going to use the one with hours on bottom so that our hours here in the given can cancel out with our hours here in the bottom, and we'll be left only with minutes. So after we put in that conversion factor, we're 2 minutes, which is the unit we wanted because we want to know how many minutes were in 2.5 hours. So then to get your actual answer, you're just going to multiply across the top, so 2.5 times 60, and then you're going to divide by the bottom. So there's only 1 and 1 on the bottom, so dividing by 1 is just going to keep it the same. 2.5 times 60 gives you 150 minutes. And that's your answer to how many minutes are in 2.5 hours. By using dimensional analysis, which is also sometimes called the factor label method, the units are ensuring that you have the conversion right side up. That's why we put the hours on bottom. And the units are calculated as well as the numbers. So it's really important in dimensional analysis that everything you write has to have a number and a unit both together. So a good way to look at these dimensional analysis problems is to break it down into the steps. So these 7 steps are the ones you're going to use for any dimensional analysis problem that we do all year. So step 1 is to write down the given amount. And remember, don't forget to put the units as well as the number. Step 2 is to multiply by a conversion factor. Determine if the top or the bottom should be the same unit as the given so that it will cancel. Step 3 is to put a unit on the opposite side that will be the new unit. If you don't know the conversion between those units directly, you can use one that you do know that's a step towards what you want in the end. And we'll show you one that has multiple steps close to the end of this video. Step 4 is to insert the numbers on the conversion so that the top and the bottom amounts are equal, but in different units. Remember, those conversion factors have to be the same thing, just in different units. Step 5 is to cancel your units. Step 6 is to multiply the top and divide by the bottom. And step 7 is that if the units are not the ones you want for your answer, you're going to keep going and keep making more conversions with more factors until you reach the units you want for your answer. So here's an example problem that you might get. So the question asks, you have $725 in your pocket in quarters. How many quarters do you have? So you're going to write your given first. So here's your given. I put it over 1 just to keep myself straight. So $7.25 is what you have. Then you're going to multiply that by a conversion factor. So the conversion factor you know from dollars to quarters is that in every $1, there's 4 quarters, right? So out of that relationship, this conversion factor can be made. Remember, you put dollars on the bottom because the unit here on the bottom has to cancel out with the unit for your given. So you need 1 on top and 1 on bottom for them to cancel. So your $1 goes on bottom, your 4 quarters goes on top, and now that you're at quarters, which is what you want for your answer, you just multiply the tops and divide by the bottom. So 7.25 times 4 divided by 1 gives you 29 quarters. So here's a problem for you to try out. If Jacob stands on Spencer's shoulders, they're 2.5 yards high. How many feet is that? Alright, so let's work it out. Basically, the problem is telling us that we have 2.5 yards, and they want to know how many feet tall that is. So your given in the problem is 2.5 yards, so I'm going to start with that. I'm going to put it over 1 to keep it as a fraction. And then I want to multiply it by a conversion factor here. I really want that factor to have yards on the bottom so that these two can cancel out eventually. So we don't want our yards anymore, we want to get to feet. So what I want to look at is, do I know a relationship that I can make a conversion factor out of from yards to feet? And most of y'all probably do know one, that in 1 yard there's 3 feet. So with this relationship, we can make the conversion factor. 1 yard is equal to 3 feet. So now our yards can cancel, and we're left with feet, which is what we wanted for our answer. So now we've got the right units. We just need to multiply the top and divide by the bottom. So 2.5 times 3 is going to give you 7.5 feet. And that's your answer. Here's another example question you could do. So it says a rattlesnake is 2.44 meters long. How long is the snake in centimeters? So our given is 2.44 meters. We need a conversion factor with meters on the bottom so that our meters can cancel, and we want to go to centimeters. So in 1 meter, there's 100 centimeters. That's the relationship that we know. Meters can cancel. We're left with our centimeters now. So now we just need to multiply the top, divide by the bottom. So we multiply 2.44 times 100 and divide by 1. That gives us 244 centimeters, which is your answer. All right, now that we've seen the one-step dimensional analysis problems, let's look at some that are more than one step. So sometimes you'll see these where you have a question and you can't get to the right units in just one step using one factor. So here's an example. It says, how many seconds are in 1.4 days? So we know our given is 1.4 days, so we can start with that over 1. But then we don't know how to get from days to seconds. We don't know what that relationship is. So we have to make a unit plan. So here, what we do know is we can get from days to hours, right? In one day, there's 24 hours. Okay, now when we're at hours, we can go to minutes. In every 1 hour, there's 60 minutes. And from minutes, we know the relationship with seconds. In every 1 minute, there's 60 seconds. So using all of those different relationships, we can use multiple steps to get to our answer and our units that we want, which is seconds. So here's a way that commonly people would try to work out that problem. So try to figure out, take a look and see what's wrong with setting it up like this. What is the problem here? So if you look really closely, the problem is that our units are not going to cancel out because our conversion factors are flipped the wrong way. So remember when we said our given unit needs to match the unit down here so they can cancel? Up here we had days, and then here we had hours. So this actually needs to be flipped so that days can cancel. So the right way to do this is to start with your given. So that's what they did here. You can put it over 1. And then on this next one, you have to make sure days is on the bottom. So we can go from days to hours. So same thing, 1 day is 24 hours. Then we can go from hours on the bottom, so that'll cancel with this hours, to minutes. So in 1 hour, there's 60 minutes. And then we want to go all the way to seconds. We'll put minutes on the bottom, seconds on the top, and in 1 minute there's 60 seconds. That way when you look at it, all of your units have 1 on top and 1 on bottom, so they can cancel out. Except for seconds, which is what you want in your answer anyway. To finish this problem, all you would do is multiply all the tops and divide by the bottom, and that would give you your answer.